Okay, so I am doing things a little bit different. My setup is a little bit different today. It's not set up the same way as I usually do. Let's see. Share my screen. Okay. So with the way I have it set up, with the way I have my presentation set up today, basically I won't be able to hear you. So I'm using a wired microphone. I feel like I know it does a better sound. The AirPods seem like the sound will go in and out, and the batteries were always dying. So I decided I have this little adapter that allows me to do a wired microphone. So I'm using a wired microphone just for a better sound, but my setup, I don't have an earpiece, right? So I have it set up where sound can come in, but I can't hear anything. So um, I say that to say, if you need my attention, you're gonna have to use the chat for right now, and I'll just try to go out of my way to check the chat. Um, okay, we'll go with what we have. So now, as far as announcements, we are officially in the home stretch, right? So I think with some of my planning, originally I was planning on us having next Friday, but I think the official last day of classes is upcoming Wednesday, which is a week from today. So that means we only have 3 sessions remaining. We have today, we have this Friday, and then we have next Wednesday, right? So because we only have 3 sessions remaining, originally what I was going to do was go through section 9.5 with you all live. I went on and did the lecture last week. It wasn't until actually I started you guys' class on last Friday that I realized that that was a holiday. It was Good Friday, right? So I went on and made the recording for section 9.5. It's a supplemental material, it's a supplemental section. It's coming from another text, but all you really have to do is log into Pearson and do your assignments like normal. Because I just went on and integrated into Pearson, so you don't really have to do much of anything different. But for that lecture, you are going to have to watch that lecture on your own and take notes and try to ask me questions during class. But yeah, because we only have 3 meetings remaining, instead of me doing 9.5 live, I'm going to rely on the recording. And I'm basically what I'm going to do is take each of those, like each day, use each day to review an exam, right? So today we're in preparation for reviewing for the final. All the final is basically it's cumulative, right? So from the beginning to the end. So I just took all the content from exams 1, 2, and 3 and mashed it into one exam. It should take you a little bit longer than the regular exams. Like usually you're allowed double time. But I mean it's still kind of the same setup. Um, let me check Zoom really quickly. Okay, let me get whoever this is. Okay. Let me see. So the things I feel like I need to say, right? So I think we still have that hard deadline of May 1st at 11:59 p.m., right? So what that means is that all old assignments are gonna lock out, right? On that, it's a Sunday night going into Monday morning. It's May 1st at 11:59 p.m. Anything old on Pearson is gonna lock out, right? So then like 1 minute later, your final exam is going to become available and you'll have access to it for about 5 days. Hopefully you've been keeping like a homework notebook or something because you can like reference it. But if you're relying, like even if it was digital, just you just want a organized catalog of the work you've been doing, because once Monday hits, you're not going to be able to access anything old. Like everything's going to be locked out. Um, and then once the final becomes available, the only thing you're going to have access to is the final. That'll be unlimited attempts, but again, that also has a hard deadline of, I think I set it for like late that Friday, maybe at 11:59 p.m., something like that. And again, because of the way I have my device set up, my presentation set up today, you're going to have to make use. Get the student. You're going to have to make use of the chat because if you try to unmute yourself, I'm not going to be able to hear you because I'm using a hardwired connection today. Let me hit save over here so I don't lose my work. Save. What time is it? I have the time is, okay, I'll just check again in like 10 minutes. Okay. Let me see if there's anything else that I need to say. So yeah, the hard deadline of May 1st for all old material. And then 1 minute later, your final exam is going to become available. It's unlimited attempts. There's no late penalty because when it's due, that's when everything is closed. Like everything's closed, right? Because I had to submit grades at that point. So that's why we have these timelines. Okay. So originally, and then so today, I'm going to do the best I can to review exam 1. I'm basically going to take the exam that's on Pearson. I was going to start on question 6 because I made it through like 5 questions with the students earlier, and then I realized basically I do a pool of my exams. So each time you take the exam, it changes it up. So I can, what that means is that with you all, I can just start from the beginning and it should give me a different set of questions. So that's what we're going to do. Again, if you have questions, comments, or concerns, just use the chat and I'll be checking the chat periodically. And you know, we can proceed in that fashion. So again, we'll take today to go through exam 1 as much as possible. Exam 1 covers sections 1.7, 2.5, and 3.1. So for instance, for this first question, it asks us to use the horizontal line test to determine whether the function is 1-to-1, right? So a function being 1-to-1 means it passes the horizontal line test. Passing the horizontal line test means no matter where you draw a horizontal line, it touches the graph once. And being 1-to-1 means the function has an inverse. But if you look at this graph, you can draw a horizontal line where it'll touch it more than once. So that means that this function is not 1-to-1, which means it does not have an inverse. So we're going to go into the next one. And again, we can't get feedback until the end. So we'll see how we did on these in the end. For this function, find the following, right? So when it asks us to find f of 3, basically replace x with 3 and then simplify. So 3 to the power of 3 is 27, minus 5 is 22, right? And so then that was a good omen that the next one was f inverse of 22. So if you plug 22 in the inverse, it's going to undo it and put it back to your original starting point, which would be 3. Okay. And then f of f inverse of 562, basically f inverse undoes f. So you should get back to 562. Okay. So I'm going to submit this and hit next. And I'll check the chat and attendance again in about a little over 5 minutes. So the graph of a 1-to-1 function is given. All right. So this function is 1-to-1, which means it passes the horizontal line test, which means it has an inverse, right? Draw the graph of the inverse function for convenience. And as a hint, graph y equals x. The graph of y equals x is also given, right? So if we wanted to graph the inverse, all we got to do is just switch the x and the y's, all right? So if we just plot the points where we switch the x and the y's, that'll give us the graph of f inverse, right? And so basically that's the same as rotating about the diagonal line y equals x. And so the only one where the coordinates, the x and y coordinates switch is going to be C. All right, that's how the image, like if you kind of have to use your imagination almost in a 3D sense, where if you flip this blue graph over the diagonal y equals x, you're going to finish with the red graph. That's the only one that flipped in the proper fashion. Okay, so we're going to go with that and hit next. Again, I'll check Zoom in just under 5 minutes. Determine whether the function shown below is a 1-to-1 function. If it is, find its inverse, sketch the graph, blah, 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 right? Okay. So if we're considering this function f of x equals the square root of x plus 3, we can use the graphing techniques from College Algebra 1 to get a sense, right? So if we use transformational graphs, the graph of square root of x is the top half of a sideways parabola, where it starts at the origin and then it kind of is basically, again, just the top half of a sideways parabola. But then if we add 3 on the outside of our basic function, that's going to move the graph up by 3, right? So instead of starting at the origin, it's going to start at y equals 3 and then just behave as the top half of a sideways parabola. So if we have the top half of a sideways parabola that starts at y equals 3, then no matter where you draw a horizontal line on that graph, it's only going to touch it once, right? Let me see. So that's just kind of like using a graph to determine if it's 1-to-1. Um, I feel like I should. Another technique is like basically if you if you start with f of x1 equal to f of x2, and then you simplify it down and you finish with x1 equals x2, that's algebraically how we show that a function is one-to-one in an algebraic sense, right? I feel like I should do that. Let me do that really quickly, just to showcase algebraically how do we show that a graph is one-to-one. We've seen graphically where you do the horizontal line test. So algebraically, we have what? F of x equals the square root of x plus 3. So let me see. Right. So if we want to, I'm going to say to show, let me see, to show that it's one-to-one. This is algebraically. We start with f of x1 equal to f of x2, all right? We start here and then we basically plug this into the function. And if we can simplify it down where we finish with x1 equals x2, then we can say that the function is one-to-one, right? So what we mean is like square root of x1 plus 3, we're going to let that be equal to the square root of x2 plus 3, right? You can subtract 3 on both sides, then you'll have square root of x1 equals the square root of x2. Let me see. Because if you square both sides, so like normally if you take the square root, you get plus or minus. Let me think about this. Yeah, that's going to kind of force it to be positive. Trying to think if there's a better way. Yeah. So like if we square both sides, yeah, then we'll get x1 equals x2, right? I think that's okay. Yeah, I think that's fine, right? So we showed that x1 is equal to x2. It really only kind of becomes an issue, like if we take the square root, then we have to do plus or minus. That plus or minus is what causes it not to be one-to-one. But in this case, I think we're okay. Okay, but that's essentially algebraically how we show something is one-to-one. So is this function one-to-one? We're going to say yes. What's the inverse of the function? Okay, let's see how to find the inverse. So let me see, to find the inverse, we can minimize that for right now. So here, we're starting with f of x equal to the square root of x plus 3, right? We replace f of x with y, okay? And then we switch all x's with the y's, right? We switch them. So then we're going to have x equals square root of y plus 3. Then we solve for y. Subtract 3. Square both sides. So then we're going to get y equals x minus 3 squared. Okay. So then this is our f inverse. Okay. Let's see. So the domain of the original, so if you think about square root of x, the domain of square root is what? 0, because we can't take the square root of negatives. So it's 0 to infinity. And if we just move it up, it doesn't change the domain. But then that range ends up being what? 3 to infinity. So once you have the domain and range, let me write it like this. Let's do this. So let me see. So the domain of f, right? In this case, the domain of f, 0 to infinity. And in this case, we can include, it can be 0, right? Because we can take the square root of 0. And the range of f in this case, that's the very bottom to the very top. In this case, it's going to be 3 to infinity. So the domain of f is the same as the range of f inverse. And the range of f is the same as the domain of f inverse, right? So, it's a couple of ways you can make that connection, but that's the main thing. I just wanted you to know that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. Okay. So let's hop back over to Pearson to answer the question. I'll check the Zoom in just a moment. Let's see. What is the inverse function? I think we got x minus 3 squared. I don't know if you can hear in the background. If you hear snoring, my dog is passed out over the little chihuahua. She's just like snoring like a grown man. It is hilarious. It is too funny. She's funny. I need to make a channel for her. Okay, we got x minus 3 squared. And then the domain, right? Okay, so the domain of f inverse, because we might need to identify that. The domain of f inverse is 3 to infinity with a go with C. Okay. So then the original f, the only one that's graphed properly for, wait a minute, red is f? Okay. If the red is, wait a minute, square root of x plus 3. Okay, there it is, D. I was about to say B, but B isn't correct either. D looks like the only one that's correct, right? Where if the red is f, the top half of a sideways parabola starting at y equals 3. If you rotate about the line y equals x, you get the blue graph, right? So I'm going to go with D. So then when you rotate about the line y equals x, we'll finish with the right-hand side of a parabola, right? Okay, let me check Zoom. Let's see if what's going on there. Okay, it looks like we got some activity. Let me get the student. Let's see. So what I have to do. This section, want today. Next. Edit. There he is. And I'm gonna go ahead and hit save because I think it's just a 1. Okay. And then let me check the chat. Okay. So there was a good question. Okay. So there was a question in the chat about the current grade. It said, is our current grade the greatest on Pearson? So let me do this really quickly. No, that's not accurate. The way I'm going to calculate grades in the end, like you can use the following formula. So like for instance, we have what? Exam 1, exam 2, exam 3. You have your homework average, you have your quiz average, and then you have your final exam score, right? So I'm going to take each of those averages times its weight, right? So for instance, whatever score you have on exam 1, so I'm just going to abbreviate it. Whatever your exam 1 score, I'm going to say times, that weight is 20%, so I'm going to say times 0.2. Then So then I'm going to take your exam 2. You're going to get an answer, right? I'm going to take your exam 2 score. I'm going to say times 0.2. I'm going to say all the exams are 20%, right? Exam 3 times 0.2. Your homework average, whatever that average is, I'm going to say times 0.1, right? Whatever your quiz average is, I'm going to say times 0.1. And then whatever score you get on the final exam, I'm going to say times 0.2, right? That's 20, 40, 60, 70, 80, 100, right? So that's where your grade is coming from. And then I'm going to take all those answers and add them up, right? So your grade, let me see, so your overall grade is going to be calculated as follows. Basically, it's going to be 0.2 times exam 1 plus 0.2 times exam 2 plus 0.2 times exam 3 plus 0.1 times your homework average plus 0.1 times your quiz average. Like whatever average it has for homework and quizzes, I'm just going to pull that data and plug it into this formula. And then plus 0.2 times your final exam score. And that's going to give me your overall grade. So if you're trying to make a plan as far as what scores you need to make to get whatever grade you want, the exams make up 80%. Like if you take exams 1, 2, and 3 plus the final, that's the bulk of your grade. So if you don't go back and do like the quizzes and homework, you want to maximize those scores. You can like plug in what you have into this formula and then play around with different potential scores on the final. Like say you got an 80 on the final, you will put 80 times 0.2. You see what I'm saying? And so you can play around with different scores for the final so you can get a sense of, well, what do you need to score on the final in order to get whatever grade you're trying to get, all right? So this is how I'm going to be calculating grades, I think. I think this is according to what we had in the syllabus, right? Okay, let me hit, I think we're okay there. Okay, so that was a question about, so yeah, what you see in Pearson is just like the average of those different categories, but I'm going to take that data and plug it into this formula. Okay, let me check Zoom one more time. Yep, no worries. Okay, so let's keep going. We can go for 15 more minutes. Yeah, right at about 15 more minutes, right? Okay. So I think we went with D there. And again, we can't really see the score until the end. The domain, right? The domain of F, we said was 0 to infinity. And the domain of F inverse, should be the range of F, all right? So the range of F was 3 to infinity. So it looks like D, right? The domain of F was 0 to infinity, and then the domain of F inverse was 3 to infinity, right? So we're going to go with that. All right. Oh, then the intercepts. What are the intercepts of this one-to-one? So for instance, if we're trying to find the x-intercept, that's where you set y to 0. If we have the top half of a sideways parabola and we move it up, it never crosses the x-axis. So there's no x-intercept. And the y-intercept is 3. So the first part of part A is correct. And then it should just be switched. So for F inverse, the x-intercept should be 3, and there should be no y-intercept. All right, I think B, right? So for F, there's no x-intercept, the y-intercept is 3. For F inverse, the x-intercept is 3 and no y-intercept. Yeah, let's go with B. Okay. So for the inverse, find the inverse of the given function below and sketch the graph of the function and its inverse on the same coordinate axis. Okay, so what we have a parabola that's been moved down by 5 units, but then x is less than or equal to 0. So we have the left-hand side of a regular parabola that's been moved down by 5 units. All right, so that's gonna because the domain is restricted from negative infinity to 0, that means it's gonna pass the horizontal line test. So then when we flip it, instead of being the top half of a sideways parabola, it should be the bottom half of a sideways parabola, right? Okay, let's find that algebraically. I'm gonna pull it from about here, there, there. Okay. Okay. Let's see. So find the inverse of the given function. So again, we know we should finish with the bottom half. So here, let's see. So we got this f of x equals x squared minus 5. We replace f of x with y, so we're going to have y equals x squared minus 5. We switch our x and our y, so we're going to have x equals y squared minus 5. And then we solve for y. So we add 5, that's going to give us x plus 5 equals y squared. We're going to take the square root, right? So on the left, we're going to have the square root of x plus 5. On the right, we're going to have y. But again, whenever we introduce square root, we have to introduce plus or minus. But now, because of the restriction on the domain here, the domain of f was what, negative infinity to 0. That range, the range of f, so we had a parabola, we moved it down by 5, so it's going to be from negative 5 to infinity. Like this. All right, x is greater than or equal to negative 5. So let me think. Only reason I know is because of the one we did the other day. I mean, just a moment ago. So again, we're starting here with the left-hand side, right? We have a parabola that we moved down by 5, but we're going from negative infinity to 0. So that means we're taking the left-hand side of the parabola. When we rotate that about the diagonal y equals x, that should be the bottom half, right? So it should be this negative here. Normally we do plus or minus, but in this case, it should be the negative, right? And then basically you can match up the domain and range. So the domain of f should be the range of f inverse. Let me go ahead and finish this f inverse. So this means that our f inverse should be the negative square root of x plus 5. The domain is going to be the range, and the range of f should be the domain here. Well, yeah. Yeah, I want to be like, if you think about it, like using the domain of f and the range of f inverse, you can kind of put those together. The way I got this negative though, I did it because based on the domain. Because we had the left-hand side of the parabola, then I knew that I needed a bottom side, bottom half of the sideways parabola. And then, you can just confirm the domain and ranges here match, the way they need to with here. Okay. So let's use this to kind of answer the question. I know there's a little bit like, circuitous or whatever. F inverse of x, what did we get? Negative square root of x plus 5, and x needs to be greater than or equal to negative 5. Negative square root of x plus 5. Okay. So we got here negative, we got square root of, I think it was x plus 5, where x is greater than or equal to negative 5, right? I think that's what we got. X is greater than or equal to negative 5, right? Okay. Now, if there are questions on that, we can just get my attention and we can kind of like talk about it a little bit more. Choose the correct graph. So the original function was the left-hand side of a regular parabola that was moved down by 5. So F, it looks like F is in red. So it could be A. I think A is the only one that's behaving the proper way, right? Where it's the left-hand side of a parabola that's been shifted down by 5 units. I think I got some stuff wrong here. Let me think about it. Yeah, I think we're okay. X is greater than -5. I think we're okay. I had a different image in my mind, but yeah, this looks okay. F is red. Yeah, and then F inverse. I'm going to go with A. And I think that's it for this question. Okay. We got a little under 10 minutes remaining. Let me check Zoom one more time. Oh man, people have faded. That's all right. Let's see, find the domain, right? So for a function like this, in general, the domain is all reals except any x that makes the denominator 0. So what we need to do is set the denominator equal to 0 and solve. Since we have the thing, I mean, normally we would factor. Let's just go ahead and do it, because I was going to kind of piggyback off the results, but let me just work this one out from the beginning. It's not, because it's not that bad. Okay. So something like this. Right. So again, in general, for something like this, the domain is all reals except any x makes the denominator 0. So what we need to do is set the denominator equal to 0 and solve. X squared plus 2x minus 35. We want to set it to 0 and solve. So then normally we factor it into something of this form where we have x and x. This minus tells me the two signs are opposite. So one needs to be plus, one needs to be minus. This guy's supposed to be a plus right here. So then this one tells me that the larger number is positive. I think it's what, 7 and 5? So positive 7 and negative 5. Notice that 7 times negative 5 is negative 35. 7 plus negative 5 is a positive 2. All right, so we're good to go. So then we set each of these binomials to 0 and solve. Long story short, we get x is equal to negative 7 and 5. So these are the two that we need to throw out. In other words, x cannot be equal to negative 7 and 5. So we can so the domain of the original is going to be all reals except x equal to negative 7 and x equal to 5. So we want everything except negative 7 and 5. That's going to be C. Okay. Find the domain. Okay, this one's similar. It's the same thing, just with a different factoring. So let's just try to do it quickly. Okay. So same thing here, right? So we set the denominator to 0 and solve. So we have this x squared minus 13x plus 42. We want to set it to 0 and solve. So then we should be able to factor it into something of this, with this form, where we have an x and an x. Now, this one tells me that our two signs are the same. This one tells me that the larger number is negative, so then they should both be negative, all right? We're looking for two numbers that multiply to give us 42 and add to give us 13. 6 and 6 is 36, 42. So 6 and 7, right? So we can say 6 and 7. So negative 7 times negative 6, 36, 42 is a positive 42. Negative 7 plus negative 6 is a negative 13, right? So then if we solve this, We get x equals 6 and 7. In other words, these are the two numbers that we need to throw out. X cannot be 6, nor can it be 7. Okay. We have time for a few more. So it can't be 6, nor can it be 7. Type your answer in interval notation. Okay. So we want everything except 6 and 7. All right. So then let's go like this. Let me see. The far left is going to be what? Negative infinity up until 6. We're using parentheses because the parentheses means we get really close to 6, but we don't include the 6. And then we're going to say cup. So combine that with everything from 6 to 7. And then cup. Then 7 to infinity. Okay. Okay. I think we're going to make this the last one. So we got a little bit further this time. Let's see. Describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function. Okay. So with this one, we need to rewrite this original function, and we're gonna do like long division to rewrite, to change the form, right? We need to change this form so that we can use transformations, because the way it's given, we can't really use the transformations. We can't see it. So we basically have to do long division to see it. Okay, and because, hang on. So because we're dividing by like a linear binomial, we can use synthetic division, right? Because we're dividing by x minus 3, we can use synthetic division to do this division. Okay. So in the chair goes 0, so we're going to say 3 into, and then we just need the coefficients. In this case, it's just going to be -2 and 7. The -2 comes down. Okay. And then on the diagonal, you multiply. So 3 times -2 is -6. And then vertically, we add. These add up to 1. And this is our remainder, this one, right? So then what we're saying is that g of x equal to this -2x plus 7 over x minus 3 is the same as, that's our remainder. So it should be the same as 1 over x minus 3 minus 2, like this, right? So then if we're starting with the reciprocal function 1 over x, the two transformations that we did, we have a -3 on the inside of our basic function and a -2 on the outside. So this -3 on the inside manipulations move it side to side. And it's a reverse of your intuition. So this -3 tells us that we go to the right by 3, and then the outside manipulation follows our intuition and causes a vertical change. So this says we go right by 3 and down by 2. So you start with 1 over x, you go right by 3, and then you go down by 2. Okay. But again, the only way you could see this, you had to do long division and then interpret the results, right? So we said right 3, down by 2. Let's see if we can find that. The horizontal transformation, we said right 3 units. The vertical shift was down 2 units. So that was it. Okay, so I'm going to go ahead and submit the exam because we're essentially out of time. We can do this one. So the vertical asymptotes, right, is any x that makes the denominator 0. You might be tempted to try plus or minus 1. If you plug in -1 into this, it does not give you 0 in the denominator. If you plug in +1, it does not give you 0. So there are no vertical asymptotes for this one. So I'm gonna just go ahead and submit that one. Horizontal. The horizontal asymptote, basically you got to compare the degree of the numerator to the degree of the denominator. In this, and it's a three step, there are three tests that you kind of do. In this case, this is like case number 2, where the degree of the numerator is equal to the degree of the denominator. So then your horizontal asymptote is going to be the ratio of your leading coefficients. So in other words, in this case, it's going to be type an equation. So it should be y equals a -2/7. I'm just doing these because they're quick. Y equals -2/7. Let's see if I can get this to behave properly. Let's do like this, -2/7. There we go. Okay. Okay, we're gonna stop there. Let me go ahead and submit this. So we got through halfway. Okay, yeah. I think we got everything correct that we did. Let me see. It says 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't think we did question 11. Score. Is there something we didn't get points for? Oh, I guess maybe there's another one or something. That's weird. Seems like, anyway. Did we do question 11? I don't think we did question 11. Yeah, we didn't do that one. Oh, maybe, you know what? I think because it's late, it took the late penalty. I think that's what caused that. Okay. Oh, so let me check Zoom one more time to see if there are any burning questions, which there probably are not. Okay. So if there aren't any burning questions, we're going to end the session here. Let me see as far as any other announcements. So yeah, we're in the home stretch. The last day of class, I'm under the impression that the last day of class is next Wednesday, which is 7 days from today. So we're going to meet this Friday, and then we're going to meet next Wednesday, and then that'll be it before the final. I set the hard deadline for all assignments on Pearson to be May 1st at 11:59 p.m. That's Sunday night going into Monday morning. 1 minute later, your final exam should become available. And then, you have until late Friday to work on that assignment, okay? So again, if there are not any burning questions, let me check one more time. We're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Peace.